anyone to read for me question 2 so that we discuss it? So the major ones are just question 1 and 2. The rest are an application of the same 1 and 2. So anyone to read question 2 can raise your hand and start reading. Shadrach.
I can read, sir.
Yes, okay, you can.
Question 2.
Yes.
Two forces of A, which is equal to 35 newtons, and B, which is equal to 45 newtons,
Yes.
are acting at a point such that the angle between them is 65 degrees.
Between them.
Find the 65 degrees.
Yes.
Find the magnitude and the direction of the resultant force.
All right. So now there's even a diagram to back that one up, isn't it?
Yes, sir.
Yeah. So to go about this question, we have this problem. So what we'll do, we'll complete a parallelogram of that diagram. Are you getting? Because we only have 2 sides. So we complete a shape by drawing parallel vectors, because those 2 are vectors. So you draw parallel vectors. You know, parallel vectors, equal vectors, those are the ones you're going to draw. Parallel and equal. So you draw something like this. You complete a parallelogram. This one should not even be in bold. They can even be in dotted. So this is what the first step that you do there. Then, who knows parallelogram law? The laws of a parallelogram. Who knows any parallelogram law? Yes, Crispin.
I know about yes, I know about 2. I think.
Yes.
It says 2 angles in a parallelogram are equal.
Yes, 2 angles in a parallelogram are equal.
Yes, and then 2 of each parallel lines are equal.
Okay. Shadrach, what did you know? Oh, I think you raised your hand for the first part. So the first rule, guys, is that opposite angles are equal. Opposite angles are equal. So this 65 is equal to the angle which is there. Opposite angles are equal. So if that is 65, then this one is also 65 degrees. Then the next rule, guys, is that adjacent angles add up to 180. So to get this angle here, you say 180 minus this angle. So what is 180 minus 65? 180 minus 65. And what was
115.
115. So it means angle ili hapa ndaka hii ni 115. So it means we have completed our parallelogram. Have you seen how we've completed the parallelogram there? Ni sharp. So now to get the resultant chi vectors, you can only add the head to the tail. So that's the reason why we even completed the parallelogram. So we will just transpose this one to that end, or you can transpose that one to that end. So what it means is the simple rule, the simple rule is that the resultant is the diagonal from this end to that other end. So you will draw a diagonal. The longest line, Mukati. So that is your force R. Navigate for FR. FR is resultant force. Resultant force. So this is what you have. You can check it out, isn't it? So when you do this, you have done 3/4 of the work. When you do this, you have done 3/4 of the work. What you have done now is that you have cut this parallelogram into two. You have two triangles. You have two triangles. This one and this one. So to find the resultant, have you seen there's something in the question? Because it's magnitude and direction. So to get the magnitude, is to get the numerical value of FR. Then to get a direction is to find an angle which FR makes with any of these sides. Because guys, when you just look at this, some of the people would think I could divide that by 2 because it's just divided by 2 here. And yes, that's not what you do. The angles are different here. So this now, this shape of triangle, it has this side, it has this angle, and this FR. Which maths do you remember? What mathematical laws do you remember that can help us to solve this? Crispin.
We can use the cosine rule.
We can use the cosine rule. Sharp. So now imagine using the cosine rule. So it means this squared equals this squared plus this squared minus 2 times this times cos 115. So we can write that. Then to ka a na ka b, it wouldn't be fair not to one to a na ka b. So to have to pick up a squared. So to have pick up to a padef. So to run doctira FR squared equals a squared plus b squared minus 2ab cos theta. Cos theta. You can put that. If you want, you can say cos c. You can use that. Then you put the values there. So you say FR squared equals 35 squared plus 45 squared minus 2 times 35 times 45 cos 115. So when you do this mathematical operation, you get a value. And remember that cos 115, if cos just goes beyond 90, it becomes negative. So whatever it is that you're going to get here will be negative. When you multiply it with that negative, the operation you must finally do there is addition. So that's the way it is. This is how you get this value. I'll leave some of the work so to practice, because I want you, as you are drinking your cappuccino at home or your iced tea or whatever it is that you are enjoying there, whatever luxuries that you have, as you are eating your Butons, all those things, the good things of life that you're enjoying, the Viennas, as you are eating them, as you are doing that, you can be going through this work. Are you getting? Are you getting, guys?
Yes, sir, we are getting you.
Okay.
Yes, sir.
So now the problem, like this, you find that question number that find the magnitude 8 marks. Find the direction 5 marks. Total marks 13. The direction, guys, is the angle. So you can choose either angle, but from logic, you can see that the angle here is easier and appropriate. So you can call it alpha. Then by then, it means you've already solved this. These methods I'm giving you are just a simple methods. There are also people who finish this thing a triangle, so wapanga rectangle triangle, over. That will do that. But for us, these are the easier methods. You just use cosine rule, and so for this one, when you have found this side, it means this one is opposite with this angle, isn't it? So this alpha will be opposite with that. Okay, let me not use alpha, let me use theta. So the theta will be opposite to the 35. Then now you can use the sine rule, which you say sine theta over 35 equals sine 115 over FR, whatever value of FR you get over FR, this one, sine 115, sine theta over 35, because the theta is opposite to the 35. The theta is opposite to the 35, and the 115 is opposite to the FR. So this is what you actually do, this operation. Then you find sine theta is equal to something. Then you, to get theta, you say theta is equal to sine inverse. I'm sure you know how to create a second function sine of whatever it is when you know how to change the subject of the formula. So meaning in physics, the most operation that you do is to change the subject of the formula. Yes, Luxon. No, it's not Luxon. Junior, Stephen Junior. Stephen Junior. Yes, Stephen Junior.
Given the qualities of okay, given the like this paragraph that's got so many equal stuff, and then bisecting the 65 degrees, doesn't that make it make this angle just the half of the 65?
That was
utilize that.
And that's a very good question, Sam. That was the fear there. I told you that as long as the sides are different, unless these two sides A and B were equal, then when you divide there, remember I saw this triangle, isn't it? Or whatever. So if these two sides were equal and those two sides equal, we would have thought likewise, like you have said. But then 35 and 45 are different. So it means this does not actually divide into two equal sides. When you do your sine rule, you will see that they are actually different. Why? Because the sides you are bisecting. Remember that when you're bisecting angles, you look at the sides the most. If you have equal sides like that, it means even the angle when you have it there, it can easily be bisected into equal parts. But then you have 35 and you also have 45. So it doesn't actually bisect into equal angles. I think that's the logic there. Shadrach, do you have a question, or you just raise the hand line up first? It was the first time.
It was for the first question. Yes.
I understand. Kaide Monica hand. What else do we have, guys? Anyone? Wanamayo?
Sir.
The previous graduating student was the first extension class. Number you girls, Mudisana mute. Yes, Cleopas.
So the question is asking us to find that is direction and magnitude, right?
Yes. Magnitude is what you found when you use the cosine rule. Magnitude is the size of this FR. Then the direction is an angle. So when you get theta there, then you say whatever angle you get with the 45 Newton force. Because you're finding the direction of the resultant. So you say this is whatever angle with the 45 Newton force. It's sharp. So there are different ways of expressing direction. You can express directions by saying minus this, then someone will know that it's going to the negative directions, whether west or east if it's west if it's horizontal, or south if it's vertical. Then the other one is use the compass, where you say north of west, south of what? Even just to say Tokabwe, that's a direction. So there are so many things. But in this instant where you see angles everywhere, when you're asked what is the direction, the first instinct is you must find the angle. The direction is the angle in this regard. Am I clear?
Yes, sir. Yes, sir.
All right. What else, guys? What else? But was extensions? Yes. I'm waiting for questions and clarifications. All these things. So now, not time you can read for me the third question. You can read for me the third question. Nala draw afye nishimwashwa nokushwa tu afu achana ndaposhi umuntu. Someone to read for me the third question.
Says find the tension in the chords T1 and T2 for the systems shown in figure below. Neglect the mass of the chords.
Bagamba mundi ba accent. Jimunyana ni mwemena chipata ke mundi ba accent. Tumwa mpoka nendala maimu bagamba.
Oh, sir.
Nati na Someone ndala muntu wapa America man. Bagamba pata. Maintain that. That's
all right, thank you.
Yeah. So we have a chord, the chords there, and the mass. The first thing you do is that the mass must be converted to weight. How do you convert the mass to weight? You multiply times 9.8. It's the one that we use at college, 9.8 and not 10, okay? So you just say it's 16 times 9.8. So you are going to have 156.8 Newton. So I've drawn it like this. I'm sure you've seen. Why are we converting? Because we're interested in weight, which is a force, and which is a vector. Mass is a scalar quantity. So we do not include the mass. Also, come on, another question. Because T1, how much T1 have you seen what T1 is? Have you seen what T1 is, guys?
Yes, sir.
Okay.
Seen it.
He is a direct. Could mass in T3 there? Guys, here upon T3 there. This is T3, isn't it?
Yes, that's it.
T3.
It's T3, sir, yes.
Yes. Always, guys, T3 is equal to the weight. T3 is equal to the weight. 2 max weight, 2 max margin. Always, T3 is equal to what? Weight. T3 is equal to 156.8 Newton. That's all. Nishwa solver. Mind body? Are you getting it? There's trig. There's trig, and there's also there's trigonometry, and there's also parallelogram law. But parallelogram law is easier for these things. Trig because it becomes simultaneous and all. As time goes, I'll tell you the trig. So you complete the parallelogram. Can you have T2 number I draw it. Have you seen what I've drawn there? It's a parallelogram. So this side, if this is T2, T2. If this is T1, T1. Then the angles, there is 42. Then there is 2. Do you remember our grade 9 for alternate angles? Remember them? Ones that were making a Z. Ones that were making a Z. So you say this one, function parameter is 42 degrees. Function is 8 degrees. Then you draw a diagonal. What I've done, I want to explain. This angle here is also the angle there. This angle there is also the angle there. I'll explain. I'll send this angle. Then you draw a diagonal. So in this diagonal, the weight is supposed to be in that. Because it's supposed to be equilibrium or balance. So these are opposite forces and they have to be equal. So this is 150.8. So this one, we call it T2, we call it T1. Then you find the angles there and there. When you find the angles there and there, this is 90 degrees, guys. So you're able to find the angle. You're also able to find the angle there. And the angle there is always the angle there. So guys, what is the 90 minus 36? Guys, mwakola sana. Nani washa mic akolela mtu? Eh? So this is the reasoning. So remember, this is 90 degrees. So I've passed 54. I've just subtracted the 6 from 90, and then 48 from 42.90 from 90 I got 48. The angle here is always the angle there, and the angle there is always the angle there. Okay? So that's the reasoning. So you can easily use the cosine rule also there. You can easily use the cosine rule because you're able to add, remember the triangle adds up to 180. So you're able to add this plus this, then subtract, you get your angle there. Which is because here is an angle. What are my identities? There's a handout I gave you,